Quiz 35. Determine the amount of energy required for a 5-pound iron skillet to increase 75 degrees Celsius. So we have delta Q is equal to mc delta T. And so we don't have a mass, we have a weight of 5 pounds. So we're going to have to convert that into grams. And so let's see, there are 2.205 pounds in 1 kilogram. Now we have to convert to grams because that's how our specific heat is listed. And so in each kilogram there is 1,000 grams. The specific heat of iron is 0.448, and that is joules per gram degrees Celsius. And so the temperature change, we don't know the final or initial, but we do know the change is an increase of 75 degrees Celsius. So all we need now to do is get out our calculator. And so we have 5 and divide that by 2.205, times it by 1,000, multiply by 0.448, and multiply by 75. And we're going to get 76,190 joules. 76,190 joules. All right, so that's going to give us 76,200 joules. Okay, an unknown metal having a mass of 13 grams increases 25 degrees Celsius when 292 joules of energy is added. Identify the metal. All right, we're looking for the specific heat because that's what's going to tell us the metal. Delta Q equals mc delta T. We added 292 joules of energy. We have a mass of 13 grams. We're trying to find our specific heat C, and our temperature change is 25 degrees Celsius. All right, so we're going to solve for the specific heat. So that's going to be 292. Divide that by 13, divide that by 25, and we get 0.898, and that's going to be joules per gram degrees Celsius. 0.898 joules per gram degrees Celsius. That's going to be aluminum. A gold sample has a mass of 50 grams and an initial temperature of 20 degrees Celsius. Determine the temperature of the gold when 1.2 kilojoules of energy is applied to the sample. So we're going to have our delta Q equals mc delta T, and our delta Q is going to be 1.2 kilojoules. I'm going to go ahead and convert that into joules, so for every 1 kilojoule is 1,000 joules. We set that equal to the mass, which was 50 grams. And then we have, we want to find the temperature, so we need the specific heat of gold. So we have to look that up in our table. And it's 0.129, 0.129 joules per gram degree Celsius. Now this is a specific heat only for gold. So you have to look that up in the table. The final temperature is T minus the initial temperature, which was 20 degrees Celsius. There we go. We have everything we need to solve for the temperature. All right, so the way I'm going to do this is say 1.2 times it by 1,000, and then I'm going to divide through by 50 and divide by 0.129, and then I have to add 20 degrees Celsius to both sides, and I'm going to get 206 degrees Celsius. 206 degrees Celsius. A sample of silver has a mass of 50 grams and an initial temperature of 20 degrees Celsius. We want to determine the temperature, again, when 1.2 kilojoules of energy is applied. So it's the same problem as above, except it's a different substance. So it has a different specific heat. We have 1.2 kilojoules of energy. Each kilojoule has 1,000 joules, 50 grams, and now we have to look up the specific heat of silver. which is 0.234 joules per gram degree Celsius. So that's what that is. And then the final temperature minus the initial temperature. Final minus initial, that is that change in temperature. Alright, we just solved for the temperature now. So we have 1.2 times it by 1,000 and divide by 50 and divide that by 0.234 and we get an answer, and then we have to add 20 degrees. So I get 122.6. So about 122.6 degrees. So roughly about 123 degrees Celsius right there. An iron sample has a mass of 50 grams. 20 degrees Celsius is the initial temperature. We want to find the final temperature when 1.2 kilojoules of energy is applied. Same problem, just different substance again. Delta Q equals MC delta T. So we have our 1.2 kilojoules. There's 1,000 joules in a kilojoule equals 50 grams. And now we have to use that specific heat of iron, which is 0.448 joules per gram degree Celsius. Final temperature minus the initial temperature. Solve for the final temperature. So we take 1.2 times it by 1,000, and then we divide through by 50 and divide through by 0.448 equals, and then we have to add 20 degrees, 73.6. 73.6 degrees Celsius. All right, there we go. A 42.1 gram sample of silver has a final temperature of 83.9. You add 300 joules of energy. What was the initial temperature? All right, so we have delta Q is equal to MC delta T. And so delta Q is the amount of energy, which is 300 joules. We have silver, all right, and it's 42.1 grams. So we have the mass, 42.1 grams, and we know what the specific heat of silver is because we just looked it up. 0.234 joules per gram degree Celsius. Now we have the final temperature, which was 83.9 degrees Celsius, minus the initial temperature. Determine what that initial temperature is. So we have 300, and we divide that by 42.1 and divide that by 0.234. We put a negative sign on that answer, and then we have to add that to 83.9, and we get 53.4. 53.4 degrees Celsius. A metal sample requires 5 kilojoules of energy to increase the temperature 10 degrees. Determine the amount of energy required to raise the metal sample 30 degrees. Well, we have a formula, delta Q is equal to MC delta T. Now this material is, we don't know what material it is, but it's a metal sample. And this same metal sample goes through a different change in temperature. You see, we don't know the metal, and we don't know how much of the sample we have. But we do know that when we apply energy to that sample, the temperature changes. And so what we have is the mass and the specific heat is constant. So what does that tell us? The temperature and the energy is a direct proportion. So if you double the energy, you double the temperature. Triple the energy, triple the temperature. What did we do to the temperature? We tripled the temperature. It went from 10 degrees to 30 degrees. That means that we have to triple the amount of energy. So it's going to be, instead of 5, we're going to triple it to 15. See, that's a nice quick way to solve the problem. All we had to use was direct proportions. Determine the amount of energy required to raise the temperature of 800 milliliters of water from 24.2 degrees Celsius to 28.1. We have the density and we have the volume. This is going to allow us to calculate the mass because the density is equal to the mass divided by the volume. So the mass then is going to be the density times the volume. The density is 0.997, and that's grams per milliliter. And we're going to have 800 milliliters. So that's going to give us a mass. We have 800 times 0.997. That gives us about 797.6 grams. The milliliters drop out. So then we go through and we calculate delta Q equals MC delta T. We want to calculate the amount of energy, so we're looking for delta Q. We plug in our mass, 797.6 grams. The specific heat of water is 4.184 joules per gram degree Celsius. The final temperature is 28.1, and the initial temperature is 24.2. Now all we have to do is calculate it. So we have 797.6 times 4.184 times the quantity of 28.1 minus 24.2. And that gives us 13015. 13015 joules. So that's about 13,000 joules. Determine the mass of zinc at 293 Kelvin that requires 5.2 to the third joules of energy to raise the temperature to 312 Kelvin. So now we have temperatures in Kelvin, and so it's best to go ahead and convert those into degrees. And so if you remember, the temperature in Kelvin is equal to the temperature in Celsius plus 273. So what we'll do is we'll say 293 Kelvin, 293 Kelvin is equal to the temperature in Celsius plus 273. So our temperature in Celsius is going to be 20 degrees. And for the 312, we're going to have 312 Kelvin is equal to the temperature in Celsius plus 273. And our temperature in Celsius then will be 39 degrees Celsius. Now, we have to find the mass. So we have delta Q is equal to MC delta T. So we have the energy, which was 5.2 times 10 to the third joules. We're looking for the mass. It's zinc, so we have to find the specific heat of zinc, which is 0.388 joules per gram degree Celsius. So then we have to put in the final temperature, which was 39 degrees Celsius, minus the initial temperature of 20 degrees Celsius. So what is that going to give us? We're going to have 5.2 times 10 to the third. We're going to divide that by 0.388, and we're going to divide that by 19. And so our mass is going to be about 705 grams. All right. I hope you found that easy. Keep working and doing your best.